What's going on, everybody? Brian here with Spinties, and today I'd like to talk with you not about efficiency and time savings, but prototyping. Of all things, prototyping your ideas and vision for a custom patient solution before you go to fabrication. And not like a diagnostic test fit prosthesis that is most commonly used today, but prototyping for orthotics and why you have with 3D technology today the ability to prototype efficiently. So I want to share with you an idea that I had, and a practitioner had reached out to us about a static progressive splint. And if you're familiar with these orthoses, upper extremity orthoses, there's essentially a bar that is here on the lateral side of the orthosis, and you could be able to adjust the patient's flexion and extension as needed. So depending on what the doctor prescribes them, you could go an extension or flexion, or however you need to address that patient's pathology. You could do it in a variable format, essentially. So with 3D printing, you have the ability to create custom solutions. Now, this is a prototype printed on an FDM printer. So it's printed very fast, not meant for not meant to be billed to insurance. It is simply a prototype. But I created this one because I had an idea. I was talking with the practitioner and I was like, yeah, I see what you're saying. And getting that extra piece of hardware for the traditional orthosis, it takes a long time, it's expensive, then you got to assemble it. So what if you could create a single piece orthosis that you could be able to adjust the patient's extension and flexion or the patient can adjust it actually as needed, depending on their comfort level. So I went to Spinties and I opened up Freeforma, which is our proprietary software that enables practitioners to be able to create their ideas from scratch. And I created this orthosis for me. Now, it was printed by my friend Brett in Hawaii. And when I was in Hawaii for my sister's wedding, I flew over to his island and picked it up. And I was like, wow, this is amazing. Picking up, orthoses in Hawaii. But it didn't fit onto my hand. My idea didn't necessarily work the first time. And I celebrated that. Because I thought, man, what if a practitioner had an idea and then took all the time to pour a mold and then thermoform over that mold and it doesn't work? All that time, and here we are talking about time, and I told myself I wouldn't do that, but all that time into that process, you then have to go back to the drawing board and reiterate, and it's a whole thing. But this meeting is not meant to talk about time. But I made this one work. So the problem was I wasn't able to fit my hand in here because of this opening being too tight, too small. So I just took some shears and trimmed the material, and now I could be able to fit my hand in. And, this design is merely an idea. So if you look at it and you're like, yeah, maybe it's a good idea, but I wouldn't use it, that's okay. We celebrate ideas here and creativity. But you place the orthosis on the patient's wrist, and then using a strap, which this one's this is like a neoprene strap. So it's very comfortable for the patient, but in regards to control, I realize that that's a bit much. But the idea of taking the wrist in its neutral position and then pulling back and have these removable Velcro straps. So, or then pulling back and then locking that wrist in for however long, then you get your extension how you like it. And yes, the patient can be able to push back on it a little bit, but it's always going to kind of revert back to the position that is necessary. So I maybe it's not the best idea in the world, but the purpose of me sharing that with you is that I am able to have an idea, then pull out my iPad, draw it onto the 3D scan of my patient's limb, send it to the printer, and in a couple hours, I fit it onto my wrist. And which this one was printed in Hawaii, but if you had a printer in your office, you could print there and then fit it onto your wrist or onto the mold or whatever it is, and quickly decide if this is an idea worth pursuing further, or if iterations are needed, then you could go back and iterate, like here, where I wasn't able to fit my hand in, iterate quickly. This is important when talking about the value of digital technology for orthotics and prosthetics. You may not always create a definitive device for every single patient that you see with 3D printing. You may sometimes want to create a very thin and low profile device to test your idea, and it would look a lot like this. So after it's placed onto the wrist, it's very low profile. As you can see, looks nice. It's just an idea, right? So let me share with you how you would do that on the Spinties workflow. You take this little guy off, just did the button here, and that takes a minute. Okay. Ideas, ideas, ideas. If you're an idealist and a thinker, and you like to take your ideas and put them into action, um, then you and I think alike. And I appreciate when we have the opportunity to connect with like-minded people, and we start bouncing ideas off of each other, and it's like, whoa, I'm literally seeing what you're seeing, and we're just talking through the phone. And I really enjoy that part of collaborating with our clinical partners. Okay, let's jump into the Spinties application. And from here, I'm going to jump into a new order. Let's just say prototype for a 35-year-old male. For the right upper extremity, select the segments of the limb that are going to be immobilized with the orthosis. Our validated product populates. I'm going to choose the A1. Here, I don't have someone to scan, so I'm just going to do a demo scan, as you can see there. Again, prefacing this video, it may be a bit laggy as I'm sharing my iPad screen to my computer. So bear with me. You can always download the Spinties app on your iPad and have demo scans like this readily available to you, so that you could be able to test your ideas on a demo scan, or just learn 3D technology at your own pace. What I really like about the Spinties app for upper extremity is that you have full freedom and control to design and modify upper extremity orthoses. So for an instance, let's just say, here's a clinical example. Your patient is severely contracted, and you get a scan of them because it's easier to scan than it is to cast that patient and get them into the correct position, and hold them there while casting. So you take a 3D scan and then place your anatomical landmarks, and then you could be able to select specific joints and digitally modify the scan, and change the position as necessary. You could do that for the wrist, the MPs. So that type of full freedom and control is there if you want it. It's not required for every step of the workflow, but you can be able to do that at your own pace. I'm going to add a little bit of offset there because that's one thing I realized with the prototype that I made was it was a little, I mean, it was, interacting with my styloid, and that was a little bit uncomfortable. So I'm going to add a little bit of offset to make sure that when I'm creating the orthosis onto the 3D scan here, it's going over the styloid and not interacting with that part. We'll locally print it on our printer, FDM, polypropylene. Now we have Autoforma, which is the automatic generation of the orthosis, or we have Freeforma. For full freedom and control of the design, we're going to choose Freeforma, and I'm going to quickly try to remember exactly what design I did. Well, I have it right in front of me, so don't think too hard, Brian. So I can, wow, I really did that one. I was feeling very creative that day. So I'm going to draw my idea out, and I got really creative. So bear with me. Okay. Now, don't worry if the edges here don't look exactly how you would like them to at this step. This is a rough estimate. You'll have some AI built in that is there so that you can be able to leverage the AI there to smooth the edges. I'm just going to add a little bit more material then. Very well. Okay. And because this is just an example, I'm moving kind of fast. But as you can see, I'm just drawing on the orthosis. We're going to leave that open. Just close it for this example. Okay. Add some support on the thumb. Okay. Add a little bit more support there. Let's just close that in. Okay. Now I press next step. The edges are smooth for me. And I can be able to change the global thickness if necessary, if you want it more rigid or more flexible. And then you also have the ability to change the local thickness in specific regions. So let's just say here where that flex zone is, I'm going to just draw on some increased flexibility. Okay. Then the orthosis is generated into the STL file, a raw STL file. And you could flare the edges, which would help there on the styloid, that's for sure. You can increase or decrease the boundary thickness to make the orthosis a little bit more rigid or flexible. And then another smoothing takes place. You validate, you add your belt loops. In Freeforma, belt loop additions are manual. So I'm going to add that one and that one. And then on the other side, add another. That's great. Add another. Boom. And, you know, I added one more here and another here for the strap. Okay. All right, prototype number 2. And I know this is missing here, but I wanted to just create the video to show you how I did that, how I did it so quickly. And I add my serial number and I submit my order. That is how you prototype with digital technology with efficiency and control, and using simple tools to get the job done. If this is interesting to you and you'd like to learn more, make sure you click sign up for a demo in my LinkedIn bio. And I'd love to share more about the Spenties technology with you. Wherever you are in the world, have a great day. It's Brian here, and I'll see you soon.